Boys and girls, today we are going to talk about lines and planes in 3 dimensions. What is a plane? The flat surface of an object is known as a plane. This is a flat surface, and we can call it a plane. You look at the screen here. It's a 3D object, but represented by a flat surface, which is 2 dimensions. So please look at the picture here. I would like you to show me the planes. Can you name me the horizontal plane in the figure? Yes, the answer is A, B, C, D. Let me color the surface and show it to you. Can you show me vertical planes? The 2 parallel vertical planes and another 2 pair. So where is the inclined planes? So I show it to you. Please pay very special attention to the inclined plane. It is quite difficult to handle when you are solving problems. Now we are going to look at lines as well. Lines and plane. Lines will lie on a plane or intersect a plane. So let us look at the 2D figure here, which is quite different from the real object. Name all the lines that lies on the plane. Let me show you part of the answer. AC lies on the plane. BD lies on the plane. And OE also lie on the plane. Other than that, you have some other lines which you may have noticed. AB lies on the plane. BC lies on the plane. CD lies on the plane. And DA also lies on the plane. Are there any lines that intersect the plane? Look carefully. Look at line JD. D is touching the plane, but J is not touching the plane. So JD intersect the plane. Likewise, you look at HK. H does not lie on the plane. K does not lie on the plane. But this line intersect the plane at O. And you can look at GL as well. GL is a line that intersects the plane. And the point of intersection is F. Let me show the answer for the lines that intersect the plane. They are JD, HK, and GL. Can you name me the point of intersection of the line and the planes? The answer is D, O, F. Now let us go to line which we call it normal, which is a very special line that intersect the plane at right angles. A normal to a plane is a line that is perpendicular to all lines that lies on that plane. Let me show you the plane. This is a plane ABCD. These are the lines that are normal to the plane. JD is normal to the plane because it's perpendicular to the plane. KR is perpendicular to the plane, and so on. But why LG is not a normal? And why GF is not a normal? Simply because they are not perpendicular to the plane. So now we have come to a more important part that we need to master it before we can solve our problem. The question is, how do we find the angle between a line and a plane? Let us recap. The perpendicular projection of a line to a plane is called the orthogonal projection of the line. And in order to find the angle between a line and a plane, we have to find the angle between the line and its orthogonal projection. Let me show it to you step by step. Focus on the line OA And also we look at the projection plane. We are going to find the angle between the line and the plane. It seems to be very difficult because we do not know how to identify which line is the normal. But what we can see here is that O is touching the plane, so we can leave it alone. We are more concerned about a point which is not lying on the plane, that is point A. I will rotate a little bit to give you a clearer perspective of what is the real situation. Well, will that give you a clearer picture? We are trying to identify a point on the plane that is vertically below A. Let me show you a point here. This is a point vertically below A. And I just construct a line from A to K, and we call this normal. And the property of normal is that must be a right angle with the plane. A will be projected perpendicular on the plane, and this is a point K. Okay, all the points here will be projected on the plane. Did you notice that? So this OA is projected on the plane. What is the orthogonal projection of OA on the plane? What is the answer? The answer is OK. OA is projected on the plane, and the line is OK. So OK is the orthogonal projection of OA on the plane ABCD. So we have reached the final part of the question. How do we find the angle between a line and a plane? Let us look at the definition again. The angle between a line and a plane is the angle between the line and its orthogonal projection on the plane. So do you know the answer now? So let me indicate the answer on the figure as well as show you the answer. The answer can be either AOK, angle AOK, or angle KOA. So this knowledge is very useful when you are going to solve problems in the examination as well as in your everyday life. Let us go through the question carefully and understand the problem. M is the midpoint of the side of EH, and AM is 15 cm. A, name the angle between the line AM and the plane ADEF, which is a vertical plane. B, calculate the angle between the line AM and the plane ADEF. First of all, let us focus on the figure. It is a 3D solid. Can you transform it from a 2D figure to a 3D solid? Look carefully. This is cuboid. EH, DC, AB, and FG, they are parallel lines. And they are all normal to this vertical plane ADEF. Let me show it to you step by step. What is the angle between AM and ADEF? To answer this question, let us show the projection plane, and this is the line. We are going to find the angle between the line AM and the vertical plane. So just as what I mentioned earlier, FG, EH, DC, and AB are all normal to this plane. At this point, M, it will be projected to E. So ME is the normal. Now I show you how each point from M to A will be projected onto this plane. Let me show you the projection line. And move the point. Every point here we projected on the plane. Please look carefully. So all the points here, every point on MA are perpendicular projection on this plane. So look at the triangle here, AEM. Which one is the right angle? Remember this side is a normal, so normal must be perpendicular to the plane. So let me indicate the angle to you. So this one must be 90 degrees. And what is the angle between AM and the plane? Remember, we have learned before that the angle between the line and the plane is the angle between the line and the orthogonal projection on the plane. So this is the angle. Angle MAE or angle EAM. Now we proceed to calculate the angle. Look at this right angle triangle, MAE. We are going to find the angle here. So the opposite side is EM, which is half of AB, 4 cm, and the hypotenuse is 15 cm. So we can find the trigonometric values of angle MAE, which is sine angle MAE is equal to the opposite over hypotenuse, that is 4 over 15. Please take out your calculator and count the value for sine angle MAE. And you can find the answer MAE by pressing your calculator too. And the final answer is 15 degrees and 28 minutes. We will continue later. Thank you very much.